Hello all, my name is Kostas Gombakis. I am part of the European Dynamics team. We made the CIRCULOOS Common Data Model, and I will present you now what it is and what can do for you. The CIRCULOOS Data Layer, is also part of the CIRCULOOS Data Platform that you need to be able to use and utilize in order to share the data with us. First, what was the motivation for us to build the common data layer? First, the medium and small enterprise in Europe have a very low digitalization level. Circular economy requires an access to a lot of data in order to streamline all aspects like logistics, buy and sell, etc. And we need to capture this relative data as close as possible in the shop floor as painless as possible. So that's why the, the motivation and goals are to build an easy to use common data layer in order all the SMEs to be able to share the data really relative easy. That's why we build the common data layer in two layers. The first layer and the most crucial one is for us to speak a common language. That's why we need to create a unified data model in order to have a uniform way of communicating the information. Let's say in Greek, if you want to say good, you say xylo. In English, it's good. And every other language has its own vocabulary. And not only in the same language, in different occupations might have a different way of saying this good. So that's why we built upon the smart data models to ensure fair access, standardization, and interoperability. We have this unified data model on GitHub. You can access it, you can fork it, and also we want your help in order to enrich it, in order to include all the necessary information and data model that are relative to your use case. As of now, we have three data models. We have for wood, leather, and environmental footprint indicator. These data models are quite easy to extend, and we have a tutorials also there on the GitHub in order for you to extend it. And now the other cornerstone of the common data layer is the CIRCULOOS Data Platform. So we build it based on open source and reusable components, so you don't need to pay anything to anyone. After we end this project, you can use it as it is. We provide a uniform way of sending and fetching the data from that platform based on the NGSILD standard. The user have authorization and authentication mechanism. We have integration with blockchain for trustworthiness, and we have created open source IoT agent to help the pilots and the open calls in order to provide and digitalize the data. So here is the platform. It's an, let's say, an overview, an architecture diagram of it. In the center of it is this component called Orion LD. It's the component that makes all the necessary integration and sense where the data are getting from and where. And we have other components in order to have different functionality. First, we have two components for security, Keycloak and an API proxy. We will talk later. And we have this component called Mintanka alongside its database in order to have the historical data. So as you can see, it's a small and effective data platform. And with this one, they can be also located in your premises. I will show you later. And either we have online for us in the European Dynamics servers, so you can interact. With this one, you can either send data to the platform with a secure way, or you can get data from that. So we have different flows on how to send data to the platform and how you can get data. I will present you the most important thing that you will do is to send us data. And also later, if you want, we can discuss in the Q&A session after the ones that you need to get if someone needs to get some data from the platform. So, as you know, as we said before, the platform accepts the data in an NGSILD format. The NGSILD, it's a JSON file with some specific attributes that we have to specify on the data model. That's why we need the data model. The data model will specify what will be the attributes of the data that you send here. As you can see here, we have an entity with specific attributes. So here we have an entity of type leather. This is the ID of that specific part or piece of leather. One thing that we have to be absolutely sure is that that ID is unique. So we cannot have two IDs to be the same. That's why you will get a notification from the Orion if this is a duplicate value. And then we put the attributes of that specific item, specify like here. So you have the origin, it's a vegan material, blah, blah, blah. So here it's how the data is encoded and can be sent to us. You can send the data as a raw JSON LD file. The other thing that we have developed is an IoT agent. It's open source. You can download it, modify it, and push it. In order, if you have a CSV file with a very specific arrangement of columns in order to have incorporation in conjunction with data models. And with this one, you can generate a CSV file from your local files. And with this CSV file, you can generate this kind of NGSI LD JSON files to be sent to the platform. This is how you can do it if you don't want to implement your own platform. So if you don't want to have a copy of this platform in your premises. If you want and serve you a lot of other functionalities, you can use the federated scheme that we have developed. So you can generate all your data and you can use the CIRCULOOS Data Platform for all your data and use a component that we have developed called CIRCULOOS Registration to Entities that you can specify there what type of data or what data you want to be pushed to the CIRCULOOS Data Platform. Maybe you have put the whole internal documents, internal processes from your shop floor there, but you only need to send the leftovers or the things that you want to sell to the other Circulus partner. So you can use this one in order to share only those data. And a very key component of us, we have utilized Keycloak and an API proxy conch in this process in order to have an identity and access management. So only registered users can access, can speak to the platform, and with a conch we can specify who has access to what data. So no one has access to all the data to the platform unless we give them their capability. So we have a very specific way of providing this access, and you can be ensured that your data are safely secured there and no one can hear it unless we want them to get the data. So it's a cornerstone of us, and all the data are stored there with a very good security in mind. So now we have a pilot of us that made some leather products, and we want them to digitalize them. This, what I will present you for you, it's open source. We have put it on the GitHub account of Eurodin. You can get it modified, make it your own, whatever, it's it. So what it is, it's a way of digitalizing this process. Later, I will present you another GitHub account that we have made that I have get from the open market several sensors that will be connecting and share the data to the platform. So this is one of the things that we have made. So here is a small video of how this process is done. First, you have to take a photo of the item and also to have this QR or Aruco markets. You only have to print them once, measure them, and put them to the configuration file. After that, you can place any product in this location. You can take a photo, and with this photo, you will get almost instant digitalization of this item. So this is what we have. We have the photo. We will present you the online platform that makes this happen. You put some attributes that is necessary, and next, automatically we generate the JSON NGSILD that will be pushed to the data platform, and everyone or the ones that you need and to have access to that data will be able to see. So here is the way. So you run a local on local machine. So you upload the data, and automatically the system use OpenCV, generate the outline of the leather product. As you can see, is on meters. So with this Aruco market, you can get it, and also you get some information like the area of the leather. Next, you go one by one to specify what kind of input is needed for this specific part. Maybe it's not leather and it's another part. Here you can go to the GitHub account and you can model it and update it like if it's let's say a piece of wood or what other item you have. So here we finalize it, we put a thickness. So in order, if you want, you can calculate the mass, the volume. And here we get the generating NGSILD. And as you can see, it's the ones that we have. We have put a button in order to check the connectivity with the platform. As you can see, we accept it. We also can download this file and to save it in order for further use, or to be able to see it and store it with another software. So here I use VS Code in order to format the JSON LD. It's out of the box, and here you can see the coordinates of each item. And by clicking this button, this entity goes to the CIRCULOOS Data Platform, and with this one, the data is already sent there. So as you can see, it's a very easy to use platform. It's like 3 clicks and you can get there. Further automatization can be handled. If you want, you can put the camera in a specific height and automatically have a click and remote trigger on the camera or whatever. So you can, as you can see, you can develop your own application, or we can develop this application alongside in order to verify and to be as quick as possible digitalize different aspects that you have. And also this is one of the key drivers why we develop this application, is as easy as possible to digitalize different aspects of them, of the end product, in order to be able, other users that want to use it, to be able to have a digital representation. That's why we develop these tools. All the other people that wants to use this piece of material, they have a digital representation, so they can use it in other software. If they use some automation software to develop and cut their leather, or I don't know, if you have some machine in order to have a unit for the wood, you need special pieces of wood or cut off of other materials. It's up to you to do. So later, and to finalize, we have some useful resources in order for you to check. First, if there is the fireware tutorials, that is a part of this architecture, so you can go there, here and read these tutorials. What I suggest is for you to go to understand a little bit the context and working with context. This is a very good first indicators of what you can do. And yeah, go through it and see what you like. Secondly, the second resources that we have put the CIRCULOOS Data Platform. All the code that you saw before, it's up there. You can use it in order to reproduce this platform on your own machines. You need only a Windows /WSL with Linux, a Linux machine. Even if it's a Raspberry Pi, I have put it in a Raspberry Pi 4, not the 5, the latest one, on 4. It's like if you have a 10-year computer, it can be used to run it. And as I promised, we have the shop floor demonstration. So with this one, you can go there and see. So here is the GitHub account of this platform. You can create issue in order for us to see and check and help you. So we have a detailed information of how this product is built, how you can install it. We have a small deployment in order for you to play inside. I have generated some NGSILD data, so I have a small indoor environmental quality sensor that you can use. So as I say before, here is the data that you are formatted using the JSON LD file. It's quite easy. It's not nothing strict. It's a JSON file that anyone can read, and us and the computer. And here you can have this, as I present you the Aruco markers, how you can run it, how you can do everything I show you. Secondly, what I have developed is this. It's a CIRCULOOS shop floor demo. So what I have done is go to the open market and take several sensors that I could find in order to measure different aspects of the shop floor. So I have bought sensors that can measure air temperature, air humidity, surface temperature, proximity sensor, weight, and color. This is relatively inexpensive. You can also have the different sensors to measure electrical consumption, and whatever other aspect we can get. So this is some sensors. What we have done, we have provided code that you can integrate the different, let's say, industrial protocols and not so industrial. So let's say communication protocols from hardware to the PC. So we can have Canvas, RS485, MQTT, I2C, and with RS485, you can also put there serial over TTL, UART. This is almost the same functionality, but with different physical methods. So as you can see here, we have a lot of different communication protocols, and with this one, you can have it and you can run it on actual hardware. So what will be the architecture of this platform? I have a Raspberry Pi running the whole architecture that we have shown before, and on top runs some specific IoT agents in order to speak this specific protocol. So you have the sensor that speaks, let's say, MQTT. The MQTT data will be sent to the Raspberry Pi, but someone needs to understand this MQTT data and transform it into NGSI LD. So this is why we need an IoT agent in order to speak this language. So that's why we need the IoT agent. It's a translator from one protocol to another. So we have developed different IoT agents and examples that I will present you later. So we can have anything to speak RS485, MQTT, Canvas, I2C. This is the most, I think, prolific and more easy to use sensor, but also you can also go through the extensive list of IoT agents provided by the FIWARE Foundation in order to find something that is not here. So here I have a detailed write-up of how you can do it. Here is a connection. What I have put here is a scale and color meter. So this is a sensor that you can use in order to identify the color of something. So what I was putting here is the extension of the leather product automation that I have presented before, that you can take a photo, then put the scale, measure it, how it weighs, and with this color sensor to measure exactly what is the RGB or whatever value you need. And these data are then sent to an ESP32 that makes and reads the sensors, the scale, and this colorimeter that speak SPI to the ESP32. And ESP32 sends this data with RS484 to the main Raspberry Pi, and then the Raspberry Pi sends the data to the CIRCULOOS Data Platform. So you can have here a button and explain and sends the data from the shop floor directly to this data platform. Next, I have a second node. It's an environmental sensor that sends the data over MQTT. So you have this BME 6680 sensor that speaks with I2C with the ESP32, and then the ESP32 speaks with the Raspberry Pi over MQTT. So with this one, you can hook any I2C sensor directly to the MQTT, then goes to the Raspberry Pi. Raspberry Pi translate IoT agent takes the MQTT data and then sends it to generates the JSON LD file, and that can propagate either to your local machine inside your company, or if you want this information to be shared, can be forwarded to the CIRCULOOS Data Platform. So we have this separation. Another let's say example is we have two different temperature surface temperature sensor. One is a PT100 and the other is a K-type thermocouple. Those sends their data to the ESP32. ESP32 has this specific board, that's why we choose it, has a CAN bus module, so it can directly convert what it needs to CAN bus, and we have a CAN bus interface in order this data to be sent to the Raspberry Pi. So here you can see a photo. So this is what I wanted to say. As you can see, we try to help the small enterprise in order to be able to digitalize as quickly as possible their items that they want to sell and share to the CIRCULOOS Data Platform. And I will help you either to set up, and my team to set up the platform on your premises, or to send the data from your shop floor to the platform. As you can see, we have developed several applications that are open source and are publicly available to the internet. That was in top of my mind some things that we find and discuss with their initial pilots that have some problems to send the data. So with this, once you can extend it or develop it as you want in order to streamline your operation and to be as efficient as possible to send this data to the data platform. When now you send the data to the data platform, all the other components of the CIRCULOOS ecosystem will gain immediately access to that component. So you don't need to resend the data. So if you want to get an LCA analysis, you don't need to send any more data. The LCA analysis will get the data from the CIRCULOOS Data Platform. If you want to visualize your data with the digital twin will get the data from the CIRCULOOS Data Platform. So the data platform is a uniform and centralized or decentralized repository of your data. All the data will be there. And once they are there, all the other components of the CIRCULOOS ecosystem will be able to access the data without any more fuss from your side. So you send the data there, and those data are immediately available to all the other CIRCULOOS components. Thanks a lot. And what we will do, we will have a Q&A session for you. Please go there, see the links that we share, and we will explain any question or remarks that you have for that aspect.